My name is Weicheng Li. I'm a postdoc in Jonathan Ostrem lab. I'm really interested in the protein small molecule interactions, and then trying to understand more deeply in the biophysical manner. However, I feel like this study is great. I love it, but it's very basic. There's no direct impact on the real world. So I really want to go find a way that to apply my knowledge to have some real impacts to the world. And then I feel like to working on some drug development to specific cancer would help. And then in that way I can show my knowledge, what I learned, and then to do some impactful work. So currently we are developing kind of new generation of protein degradation therapeutics, where nowadays people are most talking for targeted protein degradation, people are talking about PROTAC or molecular glue, where you bring the proximity between the target protein and the E3 ligase. Then the E3 ligase can add the degradation marker to the target protein. However, that requires the protein has a lysine on the surface, then it can be add that degradation markers. And what we are going to do is to have a small molecule. That small molecule can grab those markers directly onto your target protein. Then if the target protein doesn't have a lysine residue, but it can bind to our small molecule, it still will have the degradation marker. Then the protein can still be degraded. So we're working on that. However, to really make this new modality comes true, you need to deeper understand the mechanism. So we are trying to understand the mechanism of how the cell can add those degradation marker to the small molecule. And then with that, we need to do the proximity labeling mass spec to identify the important cofactor that make it happens. I feel like this project cannot be true without collaborations. So with proximity labeling, for this method, we need to collaborate. I need to collaborate with the colleagues from the Kemal Shokat lab and Jack Taunton lab with their help to do the proximity labeling. And then for the mass spec part, I need help from Richard and Antoine from Krogan lab to work together to make it happen. And then for the final result, maybe I need all of them help to figure out each step, the result from each step. Because I know people very well from these labs, and then only with this connection, I know what they are doing, and then I can have an idea what I can do, what I'm capable to do at here specifically. Yeah, then I know they can help me, and then hope in the future at some point I can help back. We are trying to use small molecule to rewire the cell signaling. That, for example, you're hijacking the degradation pathway to degrade the target protein, like for cancer therapeutics, or relocate or change the time scale for the specific proteins to make this cancer driver protein not drive cancer anymore. Yeah. So my overall interest is that by hijacking all those systems or reverse signaling may not need to be small molecule. It could be RNA, RNA transcript, could be DNA, or even could be virus, could be anything. So my general interest is in that. The process challenging at every step. Even at the beginning, before I joined this lab, I have no experience with cell culture, which is impossible to do if you want to do some chemical biology. And many experiments I don't know how to do. Even I know how to do, and then if you have a new target, it still takes some time to let you figure out. And really fortunate that I'm right now in a really super collaborative environment, like the Gordon lab, Krogan lab, and Shokat lab. Many lab members are super helpful. anytime I got troubles, I know which person can help me. They are the experts, and they're really willing to help me. So I'm really grateful. I'm really hoping that what I learned right now, some new knowledge, I can help back to this community.